In section 1 of chapter 2, we're going to be going over graphing the absolute value function with individual transformations. Now, whenever I give you a new function, regardless of what it is, your first step should always be the same. You got to figure out what the parent function looks like. This is the parent function we're going to be dealing with today. It's the absolute value function. The parent function is y equals the absolute value of x. That means we're not adding or subtracting, multiplying, dividing, squaring. We're not doing anything crazy. It's just y equals absolute value of x. Nothing crazy going on. If you do not know what a function looks like graphically, this is how you go about finding what it looks like. You set up a t-table, you find your inputs and your outputs. So you're going to pick numbers for x. The numbers we typically pick are -3, -2, -1, 0, and then their positive counterparts, 1, 2, and 3. You're going to take those values, plug them into the equation, find the output values, and then make those coordinates on a graph and fill in the picture. So if I use -3, that's going to turn the equation into the absolute value of -3. For those that have forgotten what absolute values do, they do one thing and one thing only. They turn negative numbers positive. That's it. They don't turn positive numbers negative. They just turn negative numbers positive. So the absolute value of -3 is 3. So here's my coordinate. X is -3, y is +3. So we're going to go left 3 and up 3. There's the coordinate. You do the same thing with the -2. Absolute value of -2 is equal to 2. So we're going to go left 2, up 2. Same thing with the -1. Forgot my little arrow. Absolute value of -1 is 1. So we're going to go left 1, up 1. You plug in 0. Absolute value of 0. 0 is neither positive nor negative. So the absolute value doesn't do anything. Because it only does things to absolute value, or sorry, negative numbers. So it's 0. It's the origin. And then if you plug in 1, absolute value of 1. 1 is already positive, so it stays positive. Right 1, up 1. Then you plug in 2. Absolute value of 2 is equal to 2. Right 2, up 2. And then you plug in the 3. Absolute value of 3 is 3. So you're going to go right 3, up 3. Now that we have a bunch of dots, we can now get a general understanding of what the graph looks like. It looks like the letter V for victory. This is the parent function for the absolute value. That's without any manipulation, any shifting, anything crazy happening to it. Now, if you look around the whiteboards around the classroom, you'll notice different variants of that. I might add 1 or add 3, subtract 4, add 5. I might multiply it by a number. The number might be a fraction. It might be negative. There's a bunch of stuff happening to it. All these problems on the boards are called daughter functions. This problem that I have on the screen right now is mathematically called the parent function, although I will colloquially call it the mother function. The mother function creates all of these daughter functions you see around the classroom. Your job in this lesson is to graph each and every one of these that are on the whiteboard until you notice the pattern that occurs. How do each of those values, what the value is, as well as how it's being combined with the mother function, how does that impact the graph? You will then be asked to graph them purely off the top of your head and describe the transformation, how the mother function turned into the daughter function graphically.